Hello everyone, welcome back. So this video lecture will start from the variance and standard deviation of a discrete random variable. So let's kind of recall the mean. So a couple of slides before we discussed about the mean of a random variable. So we're more looking at the weighted mean because we are not only look at the values that this random variable x can take, we also look at the corresponding probabilities, or we call those weight. Then this is more like a weighted mean, which is the theoretical value of the random variable x. Same thing for the variance. So now we're looking at something we can consider as weighted variance. So when we want to interpret this, that means if we want to write back to expand data set to look at the real cases, observations, then the population mean gonna be same as the weighted, the population variance gonna be same as the weighted variance which we just introduced right now. So the variance of a discrete random discrete probability distribution gonna be using the following formulas. We have two ways to do it, just same as the sample variance. So in sample variance, we have, for sample variance, let's think about this. We have a shortcut, we have a definition formula. And then a shortcut. Formula, so which is similar to the two formulas given below. So this is more considered as the definition one. So we use each single value minus the mean squared it, and then times the corresponding probability, and then take sum of all the products we have. That's one way to calculate the variance. And then another way is the shortcut version. We look at the squared value times the corresponding probability. We first take sum of all those products and then minus the mean squared. So that's the second way we can do it. For standard deviation, it's always just square root of the mean. And then for variance or standard deviation, they cannot be negative values. Then let's look at an example to apply that formula. So toss a coin 3 times, let x be the number of heads produced. Want to calculate the variance and standard deviation. So the discrete distribution we have is given below. So if we want to calculate the standard deviation of variance, one thing to calculate before is the mean. So mean of this random variable x. We already finished this practice problem, so we got a value of 1.5. So we can write down, and then we can now plug in that formula, which is right here. So the variance of x, we use sigma squared x equals sum of x minus mu of x squared times the corresponding probability, and then take sum of all those. So we just need to plug in all the known number. The first number we can have is 0, so x can take 0 minus the mean 1.5 squared times the corresponding probability, which is 0.125, and then plus. So that's the first term. Take sum. So we just add all those products together. That's 1 minus 1.5, next term, times 0.375. And then plus 2 minus 1.5 squared times 0.375, and plus 3 minus 1.5 squared times 0.125. Then if we finish this calculation, that's going to be the result. So now let's put those values into the calculator. we have 0 minus 1.5 squared times 0.125 plus 1 minus 1.5 squared times 0.375 plus 2 minus 1.5 squared times 0.375, and then plus 3 minus 1.5 squared times 0.125. So the result is 0.75. And then that is the variance. Then the standard deviation equals square root of the variance, which is 0.75. So we can get that value, 0.75 square root 0.866. Okay, now we finished the practice problem, and then now let's do another one using the other formula. So we have a random variable x has the following probability distribution. So x can take value 0, 1, 2, 3, and the corresponding probabilities will be 0.1, 0.2, 0.4. So this number is not given, but we can calculate that number because we know the sum of all the probabilities equals 1. So this value is going to be 1 minus 0.4 minus 0.2 minus 0.1. So that's going to be 0.3. So we can write that down, and then we verify whether they add up together equals 1. Then we're going to start with the mean, although we want to calculate the standard deviation because we're going to use the mean. So mu of x equals each value times the corresponding probability. So 0 times 0.1 plus 1 times 0.2 plus 2 times 0.4 plus 3 times 0.3. So that's going to be 0.2 plus 0.8 plus 0.9. That's going to be 1.9. And then after that, we're going to calculate all the squared value. So x squared. So we have 0 squared as 0, 1 squared as 1, 2 squared as 4, 3 squared as 9. Then if we go back to look at the formula, we have variance of x, or we say sigma squared x equals sum of x squared times the corresponding probability, and then minus mu of x squared. So actually, this is, since we know the expectation already, this is expectation of x squared. So expectation of x equals sum of x times the corresponding probability. Then expectation of x squared equals sum of x squared times the corresponding probability. So we can just use that. So every number we have, so the first squared value is 0 times 0.1 plus the next one is 1 times 0.2 plus 4 times 0.4, then plus 9 times 0.3. So this sum minus mu of x, which is 1.9 squared. So we can finish the calculation and then check the variance of x. So we have 0.2 plus 1.6 plus 2.7 minus 1.9 squared. That's 0.89. Then the standard deviation sigma of x equals square root of 0.89 equals 0.943. Okay, that's how we calculate the weighted variance or standard deviation. And then next section, we're going to talk about one special type of discrete distribution, what we call it binomial distribution. For this video lecture, we're going to stop here, and then we'll record another one for the next section. Thank you.